So perhaps you've seen Dara's brilliant video on parallax, how you can measure the distance to nearby stars by seeing how they wobble against more distant stars as the Earth orbits around the Sun. But there's a problem. Parallax only works for the closest of stars. You want to measure the distance to a nearby galaxy? Ha! No chance. So what's next? I'm Dr. Greg Brown, one of the astronomers at the Royal Observatory Greenwich, and today we're going to be taking another step up the cosmic distance ladder. Our eyes and brains are quite good at determining distances to objects by comparing their sizes. Say you're walking down the street, you know how far away a distant car is because you know roughly how big that car should be, and so you can compare it with how big it appears to be in order to work out how far away it is. But in space, that doesn't work so well. Almost every object out there is a pinprick, even in the most powerful telescopes that we own. But we can compare brightnesses. The further away an object is, the more its light is spread out before it reaches you, and so the fainter it's going to appear. So if you know how bright it appears to be, and you know how bright it should be, you can work out its distance from you. But it's not as though stars come with a standard wattage, right? Well, actually a handful kind of do. There's a class of star called cepheid variables. They pulse brighter and fainter on timescales of hours to weeks. And the brilliant thing is that they pulse at a rate dependent on how bright they actually are. And they're amongst the more luminous stars in the universe, so we can see them even in nearby galaxies. So, if you find a cepheid variable in our galaxy, you can measure the distance to it using parallax, and from that work out how bright it should be. Then find a similar cepheid variable in a distant galaxy, and you already know how bright it should be, and thus can find out its distance. Great, right? Well, actually that only really pushes you just a bit beyond the galactic neighbourhood. In order to go further, well, you'll just have to join us another time.